the Sci-AI Podcast. This is episode number 11, and today I have a great guest with me. His name is Jeffrey Scargle. Jeffrey works at NASA AMES Research Center in California. He's an esteemed astrophysicist and an astronomer. He does his research in X-ray and gamma-ray astronomy and active galaxies. Let's bring him onto the podcast now and ask him to do a little bit of introduction of himself. Hi, Jeff.
Thanks for inviting me to participate. Looking forward to it.
Thank you.
I guess you wanted me to say a few words.
Yes, please. Can you introduce yourself? Yeah.
It's a little difficult always to know yourself well. Introduce yourself. Yeah, I've been interested in astronomy since I was a kid. I got the bug when my parents took me to a planetarium show, and that was it. I made my own telescope and absorbed all the science and math I could in school, and just have loved it ever since. I've been working at NASA AMES Research Center for close to 50 years now. It's been a wonderful place to work over the decades now. And as you mentioned, my interests are in what some people call high energy astrophysics. The fact that when NASA first put satellites in orbit to detect things other than just light radiation, and in other words, X-rays and gamma rays and other wavelengths, that we discovered that the universe is not a quiet clockwork universe. When I first started, the metaphor was often used for the clockwork universe, this idea of the Newtonian evolution of the solar system, slowly planets moving in their orbits like hands of a clock, and everything was quiet and quiescent. But we've learned over the decades, largely due to NASA's and other exploration into other wavelength regions, that the universe is a very active, dynamic place full of explosions, sudden bursts of radiation of all kinds, random variations, which is something I'm particularly interested in, galaxies that seem to vary in brightness randomly. What can we learn about that? In one of your earlier podcasts, you heard about fast radio bursts, or a fairly recent dramatic example of something that was not expected at all, but all of a sudden we were getting very sudden, short bursts from the sky that we now know a little bit about, but are still largely unknown and have a lot of properties that need to be explored. Sorry to go on and on, but that's kind of the theme of my interest and involvement with the dynamic universe over the years.
Excellent. Great introduction. And please don't feel that you are extending it. Just keep going on, whatever you want to share with us. Yeah, fantastic. Let's ask you some questions now.
I regret that when I get off talking on one of my favorite topics, but go ahead. No, I tend to ramble on sometimes.
It's all right. You can ramble for as long as you want. We want to listen to you. Yeah.
Go ahead, Vivek. Sorry.
No worries. Yeah. Okay. So my first question to you, Jeffrey, it's a little philosophical one. So hold on tight, please. What is consciousness? Why did evolution choose to make us sentient? And why not other beings, such as plants or others?
Okay. Yeah. You warned me that you would ask that. So, and I guess everybody thinks about that concept at one time or another, and there's probably as many opinions about it as there are people. But I think one of the interesting points is how difficult a question it is. And it reminds me a bit of astronomical knowledge about our galaxy. The fact that we're sitting in the middle, or not the middle, but embedded in our galaxy, makes it difficult for us to really understand in detail our own galaxy. So in some sense, we know a lot more about other nearby galaxies like the Andromeda galaxy because we have a good perspective and we're outside it and we're not biased by being embedded in it. And I think consciousness has a similar problem, that we're in it, and you might think that would make it easy because it's right there, but also we don't have the perspective to see it kind of from an objective point of view. Mm-hmm. So what is consciousness? I think my view is a fairly mechanistic one, that there's no magic involved in it. It's simply a result of the fact that animals have to sense the world around them. They get visual clues, and they hear sound, and they taste things, and all the five senses, and gradually over the course of evolution, animals need to learn to plan about the future. I think what defines intelligence and consciousness to some extent is the ability to kind of make a mental model of possible futures and to act accordingly to maximize survival depending on what happens in the future. A simple thing like if an animal can figure out that when winter comes, it's harder to get food, and so what am I going to do about that? Well, let's plan and store some food. Part of it is automatic in the storing of fat in the body of the animal, but the intelligent part, or the conscious part, is looking at these models of the future and saying, how will I be better off if I do X, Y, and Z? And so I think a lot of what we perceive as a mysterious self-knowledge is really just part of a process of taking in sense data from the world and planning and laying out a course of action for the future. But that's just one view.
Right. And that's a great view as well. And like you said, there are millions of opinions about it. Nobody exactly knows what's the reason behind what is consciousness and how did we get it. But thank you for sharing that.
Do you think plants have any degree of consciousness? Your question implied they don't, but why not?
Yeah, exactly. I mean, I don't think it has been researched so far yet that plants have consciousness. There are no evidences that support that view.
Right. Yeah, and what I was talking about, plants do adjust to future possibilities in some sense, but it's usually sort of automatic.
Correct.
Flowers moving point toward the sun as it moves through the sky and so
yes.
on. Seems more autonomous or automatic and not a conscious thought or an intellectual thing in plants. But I wonder if the dividing line between, does a Venus flytrap make plans? Is it conscious of its abilities to trap insects and make plans accordingly? So does a Venus flytrap have a rudimentary consciousness?
Yes. And that can be true. Right. And I mean, could it be evolution? I mean, because of evolution, they have formed like this, that, they've turned towards the sun, or they close themselves when they have to trap an insect or something. Yeah, but fascinating points about consciousness, and we will see how in future we will do more research on this and try to understand what consciousness is.
Yes, that's a good.
Yeah. Thank you. So my next question to you is, why do black holes exist and how are they formed?
I think those are basically the same question. In a way, science answers how and what the phenomena are, not why, but it's kind of a natural process of stellar evolution, largely. Let me first say that what's going on right now in what's called gravitational wave astronomy, is that we're first getting a lot more information than we had about the nature of the black holes that exist in our local part or the distant regions of the universe. So a lot of our understanding of the evolution of the population of black holes is still rudimentary, but and keep in mind there are two types. Basically, there are sort of small black holes that result from neutron stars and ordinary stars that go through their natural evolution phase and end up collapsing into a neutron star or a black hole. And then there are the very large black holes at the centers of essentially all galaxies. One of the fascinating things that we've learned in the last 10 or 20 years is that every galaxy almost certainly has a mass. They're called massive black holes because their masses are millions or more of solar masses at the center of the galaxies.
Right.
Those probably arose in a different way that is less understood than the smaller black holes that exist throughout our galaxy, for example. They're easier to understand because they're closer to us. So I think that's a good way to answer your question. We know a lot about the origin of the small, like 5 to 10 solar mass black holes in our galaxy. The unexpected discovery from the gravity wave and the LIGO, the Laser Interferometry Gravitational Observatory, is that there are black holes that are much more massive than we expected. Emerging black holes that were detected by LIGO were in tens or more solar masses, which were kind of unexpected. But their origin is pretty well understood. The black holes at the centers of galaxies most likely arose from some accretion process where the matter collected and ended up collapsing to the singularity that represents a black hole in a fairly natural way. But the exciting thing is that we're starting to learn about that process. And ask me that question in 20 years and I'll have a better answer.
Right. Great. Thank you for that answer.
Sure.
Okay. So do you believe that multiverses exist? If they do exist, then do they exist in other dimensions that we can't see but are just next to us, like layer on layer, but each layer can't see the other one? Or do you think they exist like one universe ends and the other one starts, that sort of multiverses?
Okay, we have to be clear about what is meant by the term multiverse. My understanding of what most people mean is that it's something other than our universe. In other words, take our universe, and are there other universes outside of our universe which are disconnected and from which we can get no information? They don't communicate. There's no common space-time regions, for example, in a relativity viewpoint. With that definition, in my opinion, it's not a scientific question whether they exist or not, because there's no way to either prove or disprove that they exist. It's like an inherently unanswerable question.
Right.
So most of what I've seen talked about in this area is it's beyond speculation. It's talking about something that's inherently unknowable, and therefore it's practical matter from the pragmatic scientific viewpoint that you don't study something that you can never learn about. I think that's an axiom,
right.
For me at least. With the limited time we have to discover about the knowable universe, there's no point in talking about something that's inherently unknowable. One exception to that possibly is something called the anthropic principle. Are you familiar with that idea? That is one notion that is a sort of a testable prediction of the multiverse theory, but I guess I won't say much more than just it's a bit on the fringe. It's a very philosophical approach, and it merges with sort of a religious view because it's connected to the idea of a what's the phrase that's used?
Fate.
A designed universe,
right.
A creative design or something, I think is the phrase. That is there some mind behind the choice of all the possible universes that produce one where life can exist, for example.
Right.
People talk about, well, the atomic constants, if they were different, the structure of atoms and molecules would be so different that life couldn't exist, and so on and so on. But underlying all of those ideas is the notion that it is conceivable for these, for example, the charge on the electron to be different from what it is.
Right.
There's simply no evidence that is even conceivable or possible. So again, it's one of those things that it seems like pure speculation, and you can never get traction with observations. So that's all I have to say.
Right.
The basic answer to the question is no. I don't believe in multiverses.
Okay, right. Yeah. Okay. Yeah, that's a good explanation. Thank you. So can you talk about Big Bang and the inflation theory? My question to you on this topic is, how do we know by so much precision that the Big Bang has happened 13.8 billion years ago if we can't see by our powerful telescopes to the extent of 13.8 billion years, back in time? Then how do we know that it is that old? I mean, how did we come to that accurate prediction of that it is this much old?
Yes, that's a great question. Let me first say that it's not quite true that we can't observe. We can't observe back all the way to the Big Bang itself. But
okay.
May be familiar with the cosmic background radiation, which is pretty close. It's at a time fairly soon after the Big Bang. So we do, in fact, in my view, one of the greatest triumphs of modern astrophysics is the discovery of the cosmic background radiation. And studying the details of it is one of the elements to the basic answer to the question how we know so accurately about these early times in the universe. There are pretty good notions of what the universe was like a few milliseconds or microseconds or 10 to the minus some big number seconds after the Big Bang. And part of the example is that we trust that we know the laws of physics and how they go forward in time. Many of the laws of physics are predictive. If you know the current state, what happens in the future. But you can turn these laws around and run them backwards in time and decide what the universe must have been like early on so that the laws of physics evolved it to what we now see.
Right.
It's like taking a movie that you run backwards in time. And this movie is really a network of theoretical concepts and parameters determined from observations. But as near as we can tell, this backward movie makes sense and is coherent and doesn't have any fundamental problems or ambiguities or difficulties with explaining data, all the way back to a very, very short, like I say, even smaller than pico seconds from the beginning of the Big Bang. Inflation is going even farther back in time. I like to think of this as it's like a logical network of theory, observation,
right,
and human thought that is responsible for this really remarkable transformation of, over the last few decades, going from the nature of the universe and knowing whether it was created at a particular time or always existed, or all of that stuff was pure philosophical conjecture. But in a few decades, it's turned into a hard, solid science. And we do know these very solid things about the history of the universe. To me, that's got to be the most remarkable transformation of science. And it's hard to imagine it's common to say, well, Aristotle thought he was at the peak of science and that he was,
right,
and so you always think that you're in the golden era, but what more can we learn 100 years, 1,000 years from now, more fundamental than, the universe didn't always exist. It started 13.8 billion years ago. Here's how it started. Here are some pretty fine details of how it started and how it's evolved. But it's always surprising, and I bet we'll learn things that we haven't even dreamt of so far.
Right. Fantastic. I mean, sometimes I do think about this, that, we have done so much research and found out, almost everything about Big Bang. Einstein stated it, that, the universe is expanding. And then, if we go back to that time, then there was that second when the Big Bang actually happened. But then my curious mind asks me, so what happened before that second? How did that matter come to that place? I mean,
yes,
yeah, nobody knows it, to be fair to everybody, but how amazing is that how did that happen, that point from which everything emerged was actually placed there, or actually was there? How? So yeah.
Right. Yes. Well, that's a fascinating question. I guess I have two things to say about it. One is,
sure,
maybe positive. You're familiar with the concept of kinetic energy and potential energy. There are two kinds of energy. And if you set out to calculate the total energy of the universe, including kinetic energy, energy through mass, E equals mc squared, you
Right.
add up that, and you add up the potential energy of the universe. If you make the best estimate that you can of the sum of all the forms of energy we know about, the net result is zero. That sounds impossible, but
Exactly.
potential energy is negative, and so in a real solid physics, no holds barred sense, the total energy content of the universe is zero, approximately, but maybe it's exactly zero, and so maybe that's part of the explanation of how something came out of nothing. Maybe, I mean, the answer being maybe what we think of as something is really nothing masquerading as something through. And there's similar concepts in quantum mechanics with the
Right.
Spontaneous creation of positron-electron pairs, which spontaneously generate themselves out of nothing and then very quickly annihilate each other and return back to the so-called vacuum. It's not a totally satisfactory answer because, I mean, you just use the terms quantum fluctuation and random fluctuation and equal energies in the positive and negative sense, but those are just words. Is there something behind it? And again, using the practical, pragmatic, can you test it viewpoint, it's essentially an unanswerable question. Is there an origin? Is there a story that you can tell before inflation, before the Big Bang? With our current knowledge, we have no information, so we can't say anything about it.
Absolutely. Absolutely. But I'm really hopeful, Jeff, that, if you go like 500 years ago, we thought that the sun is revolving around the earth. And there were so many theories that, today science had proved it, which 500 years ago seemed like absolutely impossible, right? So I'm just thinking that maybe in 500 years to 1,000 years or maybe more, we might be able to find the reason of that as well. Like you said, why did that happen and what was the reason behind it?
Yes, to rephrase what you said, I think anything's possible. And to say it would never happen it's always wrong. Whenever you make a statement, something won't happen or can't happen.
Right.
Actually, when I was a graduate student, the concept of neutron stars was in the same boat.
Mm-hmm.
They were idealized physical things that the theoretical physicist could understand what a neutron star would be like if it existed, but the most thought was nature never could produce something as dense as a neutron star or even a black hole. And so people were saying they could exist, but they don't. We'll never see them. And that was wrong.
Right. Yep. Great. Thank you for that. Okay. So will we ever be able to travel to other galaxies and the far-flung galaxies of the universe? How is it possible?
Okay. My opinion is that will never happen. It's physically possible. You can say a lot of things about what the motivation would be. Why would you want to do it? Would you do it with some sort of scheme where you are, I forget what the term is in science fiction stories, where you're frozen for a million-year journey and then you wake up? Think about maybe somebody would want to do that, but forgetting about ideas about why you would want to do it, just how to do it is such a difficult thing technologically. And we know that the lifetimes of technological civilizations are not infinite. As much as we don't like to realize that our civilization will eventually die as a technological civilization. And I don't think there's time and, if you will, political will, so to speak, to mount the project necessary to travel even to near stars within our galaxy. Forget about your question of going to other galaxies, which is a huge, much more difficult problem than the hugely difficult problem of going to nearby stars. I wonder if we will ever travel to other stars. And as you know, the Fermi paradox says,
Right.
well, if it's possible, they would be here. So the fact that we haven't seen them means that it's not possible, or at least it hasn't happened. To me, there's a more meaningful and closer version of the Fermi paradox.
Mm-hmm.
Why haven't we heard from them? Now that we know that there are planets around almost essentially every star and probably the universe and within our galaxy. And by the way, that a major leap in that discovery was carried out at the AMES Research Center by a large team led by Bill Barucki, who is the hero of modern astrophysics of that kind. It's a long story about the difficulties he had getting the Kepler project to happen and so on and so on. But so almost certainly there are civilizations everywhere in our galaxy. And you have to accept some assumptions about what it takes to generate life in the first place, to generate intelligent life, and so on. But most people think that there's almost certainly intelligent life, or at least that's a good question. Are there civilizations that are capable of sending radio messages to us or other forms of message? The fact that we haven't, despite some looking for them, the SETI Institute and the SETI project has a long history of searching for signals. I spent a little time working on analysis of data from what's called the Allen Telescope Array. It's an array in Northern California funded by Paul Allen of Microsoft, dedicated to the search for signals from extraterrestrial civilizations. And as you know, because you would have heard if there had been any discovery, there have been no detections of signals of any kind. To me, that's a more interesting and important and direct question than why haven't we been visited? Why haven't we gotten any signals? There are lots of interesting things to pursue in that area. One that might not be obvious is something called, has a funny name, star tickling. The idea of tickling a star. The notion is that one of the big problems with sending out radio signals that will reach the far edges of our galaxy, let's say, is the tremendous amount of energy you would have to put into a transmission to do that. So one idea is that the civilization would let a nearby star do the work, so to speak. So the civilization, let's say, is nearby a Cepheid variable star. Let's say there's a Cepheid variable star. It's a variable star that cycles through a regular period of brightness change. And the civilization would understand that it could tickle the Cepheid variable. It could inject some beam of energy that would make a small change in the time at which the peak of the brightness would occur. And this could act as like almost a Morse code transmission, where the civilization would encode a message by delaying or advancing the time of the peak of the Cepheid variable. And it turns out, this is sort of ironic in a way, the best data for looking for that effect is in the data obtained by the Kepler satellite, which is the satellite that discovered all of these planets around stars in our galaxy. Because that satellite not only measures the brightness of stars in order to discover planets around them, but it also just measures the brightness of everything in the field of view of the telescope. So it's the best data set for the variability of these Cepheid variables. And anyway, that's a bit of a tangent, but a lot of these things sort of work together in a network of ideas.
Right.
And so there are a lot of people there's some new ideas about ways of searching for signals from intelligent civilizations that people are working on and so on. But the cold fact is, so far, no detections. What does that tell us? Does that tell us, well, I don't know.
We are alone.
You tell me.
Yeah.
What do you think? What do you think is the reason why we haven't gotten radio signals from ET in our galaxy?
Right.
Is that one answer is it's just a big technological problem that no civilization has managed to solve. Another speculation is they're not interested because they don't want to, there's this business about it. Wasn't it Stephen Hawking that we should be worried about sending out messages because they'll come and eat us?
Yes. Yes.
Yes,
he said that. Yeah.
A silly idea, but maybe that silly idea is more pervasive than my ideas, and so that's why no civilization has reached out to us. Who knows? It's a nice area to speculate in. Once again, with new data analysis, new data methods, and telescopes and so on, we're getting more information. So I think 50 years from now, we'll have either some detected signals or we'll know more about why we're not getting positive results. But that's a guess.
Absolutely. No, you're right, because we have these LIGO detectors for the, detection of gravitational waves that, came traveling after billions of years to Earth. And that's why the Nobel went to these two scientists, right? So maybe in the next 10 to 50 years, we will have something like this that can detect, perhaps by SETI or by some other organization, some scientists, that we have detected something. And yeah, you're right. If we haven't, then we're not special. We're just lonely. We're just alone in this universe.
Right. I think that's unlikely, but it could be. It could be.
Right.
I think it's unlikely we're alone. I should be specific. I think you're familiar with the Drake equation, roughly estimate how many other civilizations will be. It has a lot of uncertainties in it, but altogether, if you think about it objectively and put in reasonable factors, probably the most uncertain one is as you're probably aware, is the lifetime of this civilization as a technologically capable civilization. That maybe every civilization achieves nuclear weapons and destroys themselves. That's certainly a possible answer. Maybe every civilization discovers genetic engineering and destroys itself by fiddling around with the genetic code and thereby makes mistakes and destroys civilization. There are various ways civilizations could commit suicide, and maybe that's happens so often that this factor in the Drake equation is so small that we're almost alone, and there are very few civilizations in our galaxy.
Right. Yep. There can be millions of possibilities. Yeah. Thank you. So then let me ask you this question around Omomoa, the asteroid that just visited us about a few years. Do you think that Avi Loeb, one of the esteemed scientists who said that about Omomoa, that it could be an alien spaceship that is crossing our solar system? Do you think that is right, or what is your opinion of that?
I basically have no opinion because I don't know. I don't know the evidence that he's invoking for that idea. If you know and could summarize it, I could comment. But as I know, that there isn't any obvious reason why it's not an ordinary asteroid. But
right,
if you can correct that.
Yeah, he presented some evidences like the shape of the asteroid doesn't look like a normal asteroid. He also mentioned something that doesn't look like asteroid because of the fact that how it glitters, the speed of it. And there are so many other evidences, he said, we have as per his research or as per his predictions, that he says that it is not a normal asteroid, it is a spaceship. And perhaps with our limited cognition, we are not able to comprehend it right now.
Okay. I guess I'm enough of a politician to say no comment.
Right. That's okay. Yes. Okay. So let me ask you then this next question about time travel. Why does time only travels in the forward direction, and not backward, or not just pause at some time? Or let me ask you, in your opinion, what is time? If time almost stops at the speed of light, then do the light photons experience no time? I've asked you a lot of questions, so you can tell me if I should repeat it again.
No, I can answer the last one, but I think none of the others.
Sure.
Then it's a fairly straightforward conclusion of special relativity that what's called the proper time in its path is zero. The elapsed time as seen by a photon, so to speak, is zero. In a sense, time stands still for a photon. That doesn't really mean too much, because if you ask, what would it be like sitting on that photon?
Right.
That's not going to happen, because the only reason the photon can travel at the speed of light is because it has zero rest mass. Or as far as we know, its rest mass is incredibly small, or
right.
theoretically zero. So in a sense, there's a pretty solid notion of how time evolves for objects moving at various velocities, but questions about why it only goes in one direction and stuff like that, in my view, that's an example of the kind of thing that is you can't really say anything about.
Right.
It's like when Feynman says nobody understands quantum mechanics. Nobody understands why time goes in only one direction. It just does, and that's science. The goal and the reason for the existence of science is to explain how things work, not why they work. In some, I don't know in what sense that question is asked, but I think the only thing you can talk about is how time behaves. And again, our understanding is increasing greatly in the last 100 years. We now know that time, like simultaneity, is not absolute. Two events can be seen as simultaneous by one observer and not by another observer. And that's something that Newton would have choked on and was not obvious at all. So we're learning a lot about time. Whether we will be able to formulate a sensible answer to your question now, or I mean in the future, I don't know. But for right now, I don't think anybody can answer that question. But that's my opinion.
Okay. Yeah. Okay. So my next question to you is, how did life come into being from stardust? Like, it is commonly referred that we are made of stardust from, the gases or the atoms that have formed in a collapsing star. So we are made of that. So how does life begin from non-living stardust or gases in the cosmos? Like, how does non-living thing makes a living thing?
Yes. Another great question. And again, it's a case of some things are known and some things are unknown, in my opinion. I think there's a good bit of understanding about some of the ways that life originated. You're familiar with the experiments that show that inorganic materials, if you stir them up and expose them to lightning and so on, you can generate organic molecules and all that kind of stuff. And there's some interesting experiments with putting, I think that a guy named Deemer at UC Santa Cruz took some pieces of meteorite and put them in water, and they automatically formed vesicles, which are like pouches with an outer shell and things inside. Not living pouches, but something analogous in some sense to rudimentary life forms like amoebas. So I don't know if I should single out that particular experiment and so on, but it's an example of understanding of certain things that are natural occurrences, and evolution takes over because the standard theory of evolution that explains quite a bit that these things get knocked around and the good ones survive and the bad ones don't. But for any of that to work, you need to kickstart the notion of being able, these vesicles or whatever started things out, have to be able to reproduce themselves. And even more, they have to pass on to their offspring a code of some kind. The genetic code is what what survived this process, and we now understand quite a bit about.
Right.
But if you don't have something like that, evolution can't proceed, because evolution requires a change in the code of the offspring in a positive way that results in greater reproductivity, or a negative way that results in that attempted evolutionary path being wiped out. And so far, the only sensible idea for how that evolutionary process could take place is through a genetic code of some kind. So the big mystery, I think in most people's opinion, is how did that system of coding that is having information stored in the entity have enough information in it to determine how the offspring behave and how they're put together and what their properties are, including passing on the genetic code to a second generation and third generation and so on. So I'm just rambling on about, to me, the big mystery is a genetic component of the idea of how life originated.
Fantastic point about the genetic code. Yeah. Yep. Thank you so much. Thank you. What are some of the amazing things that NASA is working on today that will benefit humanity in the distant future? In the near future, we know they have planned some of the Mars mission and lots of research on ISS going on and a lot of other things. But what are they doing for a very, very distant future?
Oh, wow. When you started, I was about to ask how many hours you have, but when you restricted it to the far future, very different question. I think it's difficult. In fact, that's the whole point of research. If you knew what was going to happen, that's half the battle. I don't know. I frankly don't have any really specific guesses about what will come out. It's just, you can look at the history of science and the concept that I mentioned earlier, that anytime we get new modes of getting information, new wavelength regions, the launch of X-ray rockets and satellites and gamma ray satellites like the one that I work on. There's a Stanford project, the Fermi Gamma Ray Telescope. It's an international collaboration, and that's another example of sending observatories literally into space to get new modes of information. The best example more recently is the Gravitational Wave Observatory, not in space. It's not a NASA project, but it's the same idea. But this is now a totally new way of getting information. It's not radiation of a different wavelength or related to electromagnetic radiation directly. It's not just extending X-rays to gamma rays and beyond. It's a total new phenomenon. Wiggles of space-time is a simple way of saying it. You've probably seen that metaphor.
Right.
But anytime you do something like that and get new information, you learn a whole lot of answers to questions you've already formulated, and you learn a whole bunch of new questions that you hadn't even thought of before. You always find unexpected discoveries. And so far with LIGO, the gravitational wave business, it's mostly been verifying things that we expected. So far, there haven't been any. There have been sort of phenomena that were astonishing. Like,
yeah,
they detected a merger of two neutron stars that produced electromagnetic radiation after the merger, and so we now know a whole lot more about even things like the creation of the elements in stellar explosions and collapses and so on. But so I predict that, if you want a prediction, that in gravity waves, within a fairly short period of time, there'll be unimagined discoveries of things that we hadn't even thought about, and who knows what applications or philosophical importance those discoveries will mean. Maybe a lot of people are really interested in the notion of whether life exists on Mars, for example. That's a more straightforward thing, but maybe is too near term for your question, but I think that would be interesting. It would be very informative if life originated in more than one place in our solar system, because that would be very strong evidence that life can originate, that life does originate wherever it can originate. And so that makes it incredibly likely that life will originate all over the galaxy and all over the universe. But so far, that discovery remains. Just the fact that it's now clear that Mars used to have a lot of water running around it. That's a dramatic discovery that puts that question in a very different perspective than it was 10 or 15 years ago. But in terms of will exploring the outer solar system or whatever in the future of NASA, whether that will, what meaningful things will come out of that is, your guess is as good as mine, put it that way.
Mm-hmm. Right. That's a great point as well. So let me ask you a connected question to it is, when will NASA put humans to Mars? Is it at all needed to send humans to space when the robots built with AGI or human level intelligence can do the same work? Because they don't have to then worry about radiation, atmosphere, losing bone density that, probably can happen with humans due to less or more gravity at other planets. So what are your thoughts about it?
Do you enjoy watching, we call them travelogues on television, video stories of traveling to various remote places on the Earth, exotic locations, the Antarctic or Bali and so on?
Yes.
And I think a lot of people, especially during the pandemic, enjoyed those things more and more. It may sound facetious, but the point I'm trying to make is that more and more we don't need to travel to places to learn about them, and sending robotic cameras or just in general getting information without going there is just more and more useful and more acceptable.
Right.
And in view of that trend, it's a psychological trend maybe, or a sociological trend. My guess is that in the end, either we will never send manned missions to Mars, or it will be in the very far, like several hundred years in the future. Excuse me, I'm guessing that even with SpaceX and all the really neat stuff going on in commercialization of space travel, I just don't see that the technological difficulties will be solved and will be motivated by the need for being there. I mean, when I was a kid, I used to imagine, being on Mars would be incredible. This red planet and
right.
Be so mind-blowing that it's almost impossible to think about. The way I think about it now, if I were transported to Mars, I'd probably look around and say, yeah, this looks a lot like the JPL pictures that I saw back on Earth. So what? I want to go back. I want to go back home. I'm being a little facetious, but despite these ideas about sort of reliving the age of exploring on ships, circumnavigating the globe and all that stuff, and the explorers discovering new continents and all that stuff, despite all that romantic hype, I don't see that as gelling to a real project of going to Mars, much less colonizing Mars. My guess is that will never happen, but I know a lot of people disagree with that and are pursuing it. So again, that's just one man's opinion. And by the way, I guess in that particular question, I should emphasize that I am representing my own opinions, not those of the agency that employs me. So.
Right. No, that's a great point. And who knows what will happen in the future. But I mean, it sure looks like that most of us, because Mars and traveling to Mars has become such a lively topic in the last 5-10 years with the advent of SpaceX and Blue Origin and Virgin coming into the picture as private companies supporting that infrastructure of taking humans to space. But the point is, I mean, why do you want to send humans and risk their lives there with so many possibilities of not coming back or coming back with lots of radiations and all? So that was the only point about maybe sending robots, like they have sent it, the rovers right now, take beautiful pictures, do some research there. And if it is possible in the next 20 years, send, human level sort of robots that can do everything that a human can do and still be able to survive for as long as possible. Yeah.
Yeah. I just thought of one data point for this question. The South Pole. Right now, the only humans on the South Pole who stay there year-round are scientists. There are no explorers anymore running around the Antarctica. There are no tourists, as far as I know. There are only scientists who go there because they have to get the science they need. They need the various properties of the atmosphere and so on at the South Pole. So that suggests that this notion of the excitement of exploring peters out pretty quickly. Just a thought.
Yep. That's a great point. Yep. Absolutely. Awesome. Thank you, Jeff. Let me ask you the next question. So what is the kind of astronomy done by researchers today? What I mean is, what is the most powerful telescope that humans have developed so far? Is it the James Webb telescope, which is in, I think it's orbit right now? And what are there on the Earth? I heard and read about it that it's in Chile, one of the most powerful ones. But yeah, I mean, can we ask your opinion about astronomy as well?
The first point I'd like to make is that it's, with all due respect, the question is not unambiguous, because there are different telescopes that do different things. There are infrared telescopes, there are ultraviolet telescopes, there are radio telescopes, there are optical visual telescopes, there are X-ray telescopes, there are gamma ray telescopes. There are now neutrino telescopes. There's gravitational wave telescopes, observatory. There are cosmic ray observations, not exactly a telescope as such. I don't know, is that a dozen or so? And no one of them can be said to be the most powerful. Within any one of those categories, the most recent one is probably the most powerful. James Webb is due to be launched soon, but it's not up yet. So I guess right now the most powerful optical telescope in one sense is the Hubble Space Telescope.
Hubble, yeah.
But look at this. It depends on what you're interested in. If you're interested in finding planets around other stars, there's a mission that's the second generation from the Kepler mission. There's a telescope called TESS, TESS, for Transiting Explorer, something or other. Anyway, it's a follow-on to detect planets around stars. In a real sense, for that science, TESS is a smaller telescope. It can't collect as much light, but it gives more information about planets around other stars than the Hubble telescope does. So it's really like, I don't know quite how to put it, an analogy, but in a family, what's your best child or something? They're all different and they do different things. And it's really unfair to pursue the question, what's the biggest and best and brightest right now? It's really an important way of thinking about science is similar to what I was talking about in how we know so much about the beginning of the universe. It's a network of various things all contributing their parts. All of these different observatories. By the way, I left out another one that is in construction. It started out being called the Large Synoptic Survey Telescope, LSST, but it's now the Rubin Observatory, named after Vera Rubin. It's a ground-based telescope. It's not nearly as big as some of the biggest, like even the Palomar Observatory or the 10-meter telescope or the giant telescopes. But it has a huge field of view, and it's going to survey the whole sky very quickly and essentially take motion picture on most of the sky to track the variable objects and the moving objects all over the sky. And that's a huge project that in its own right is, in some senses, may yield more interesting science than the Hubble telescope, even though it's a ground-based telescope. But it's really not a competition. It's really working together, and all of these different contributions are part of our pieces that are put together in the sort of puzzle about what the universe is like. So I hope that's not too overthinking your question, but
no, it's a great point.
When I was an amateur astronomer, and when I had my telescope out in public, people would come up and say, "How far can you see with this telescope?" And that's just the wrong question.
Yeah.
With your unaided eye, you can see the Andromeda Galaxy, which is millions of light years away. So it's really a question of the quality, not the quantity of what information.
Sure. Right. No, absolutely great bifurcating these different kind of astronomical tools, and each have its own relevance. So we cannot just say the most powerful ones. It just depends on what context you're talking about.
Yes, exactly.
Fantastic. Thank you. So let me ask you some question related to reality. What is reality? Is it our brain's perception? I have read and heard in some program somewhere that if our brain is switched off or doesn't exist, then nothing around us exists. So is it a subjective experience, or what do you think about it?
Well, I think some of the stuff that you mentioned are examples of unscientific questions, unanswerable questions. So if your brain is switched off, does anything exist? How could you perform an experiment? I should say, you may have gathered from all of my answers that I have this, in philosophy, it's the pragmatic view, and in this philosophy of science, you can only understand things that can be measured and you can perform experiments with, and so on. So reality, what is reality? Well, I view that as essentially an unanswerable question. Mm-hmm. We get information that can be interpreted as understanding a reality, like, I don't know, just getting light from a star. We imagine that there's a real star there and we're getting light from it. But all we really know is that we get some light in the focal plane of a telescope. We don't know that a star exists. So, but to me, those are just philosophical questions that you end up twisting yourselves in intellectual knots that can't be untangled in a real way. I'm reminded of debates in the early 20th century when quantum mechanics was first being Niels Bohr arguing with Einstein. And they did have this notion about, is there a reality there? Does the electron really exist, or is it a sort of spooky wave function or something? But is there a real electron there, and questions like that? And so smart people like that have thought about, infinitely smarter than I am, think that there are some meaningful questions there. But from a practical point of view, I just accept the information that we get through telescopes and microscopes and laboratory measurements and put together a picture. It's a model, just like the animals evolving that I was talking about make a model of reality being possible future events that need to be thought about in order to survive. It's just exactly that reality is the set of models that we construct that makes sense if we think in terms of there being a real thing there producing the data that we get from them, producing the light that we get from the star, the sound that we get from a violin. Does a violin really exist, or is it the only thing we can know is the sound of the violin? Mm. Those are sort of, to me, sort of non-scientific, they're philosophical questions. So I'm basically saying I can't answer the question. I don't know what reality is.
But you still answered it really nicely by adding the gist about the scientific argument that Niels and Einstein.
Let me add one more thing. I don't know the quantum mechanical uncertainty principle. I don't know if you're familiar with.
Yes. Mm-hmm.
There's the question of the mathematics and the quantum mechanical theory says that for a given particle, you can't measure both, let's say, its momentum and its position to infinite accuracy. But if you measure its position very accurately, you don't know what its velocity or momentum is, and vice versa. So there's the question: why is that? Is there really? Let's talk about an electron. Say we're measuring the position and velocity of an electron. Is there really a real electron there? And can we, normally if there's a blob of putty, we can look and hold it in our hand and say, yes, it's real. I can feel it. I can see it. But we can't see an electron. So what's going on there? Why is there this vague thing that we can't pin it down? We can't, if we try to squeeze information about where it is, we lose information about how fast it's moving away from where it is now, and so on. And so that all seems mysterious and surprising. But if you step back and think about how we get information about positions of things, we shine light on them and we see where they are. But at the level of microscopic level electrons, it's like throwing I guess a good analogy would be let's say you can't see, it's in the dark, but a balloon is going by you, and all you can do is throw baseballs at it. And if the baseball hits the balloon, you hear it, and so you know approximately where it is, but you don't know where it's going to be soon, because the baseball hit it and maybe moved it in such a way that it's going to move away from where it is. So in other words, its velocity after you've made the measurement is uncertain because you've hit it with a baseball. And so thinking about it from that point of view, it shouldn't be surprising that electrons can't be pinned down, can't have an inherent reality that we associate with macroscopic objects like blobs of clay or balloons or baseballs, because the only way we can get information is by this strange and imperfect process of throwing things at it and seeing what happens. And so does that mean that there is no real electron because its position and velocity can't be determined exactly we can determine the position and velocity of a baseball to any accuracy we want. But the fact that electrons can't be pinned down in that way, does that mean they don't really exist or not? I don't know what to say about that. But again, if all you care about is what you can measure, everything makes sense. And the Heisenberg uncertainty principle is not mysterious at all. It's just
exactly
a natural outcome of how we get information.
Yeah, that's a great point. Yeah. Okay, thank you. Then let me ask you this question about meaning of life. So what is the meaning of life and why are we here? Would the universe had missed anything if we were not created from the stardust? So what is the meaning of life to you?
Okay, so this is obviously a fairly abstract philosophical question.
Yes.
But so to turn it around a little bit, what do you mean by when you say, would the universe have missed anything? What do you mean? That implies that the universe is capable of missing something. Is that what you mean? That the universe has the same feeling and notion human beings have, and the universe regrets not seeing something?
Right. So let me clarify that. What I meant by that is life actually started as per us, only on our planet. And on our planet, how it started some 4 billion years ago was a glitch because of some microbes not being able to replicate properly. So that because of that glitch, it happened. So my point is, let's say that accident wouldn't have happened. Without that, the universe would have existed without us being here, or without animals being here, or without any kind of living organisms being here. Because on a cosmic scale, what is our existence? I mean, even the existence of Earth is about only 4 billion. So the universe wouldn't have missed anything if we wouldn't have been here, but there should be somebody to comprehend it. And that's why we are talking about it. So my point to you is, yeah, I mean, what is the meaning of all of this then? Why are we here? And yeah, why are we being created?
Okay, so I guess I don't see any evidence for the existence of a transcendent consciousness that has the properties that you're talking about. I mean, I'm not saying I believe it's impossible, but I don't see any evidence that it exists. If you had phrased the question a little differently and asked what is the purpose of life, I think I could answer slightly more meaningfully than just say, I don't know what to say, by the fact that if you just take the mechanistic Darwinian view about the origin of life and say this problem of getting a genetic code going is that I like the term Mother Nature. It's sort of a non-religious term for a sort of facetious guiding principle. It's just the universe operates according to however it operates, and we try to understand something about it, and we call these things laws, but it does what it does, and somehow it generated these living things, these things that have the properties that we define as living in terms of reproducing themselves and getting energy from the environment, and the usual discussions about what defines life and so on. And so the purpose, the driving force behind individual examples of life is to survive, obviously. And beyond that, once this consciousness in the sense of planning for the future becomes advanced and sophisticated, the drive to understand, the scientific drive, builds up and gets more and more intense. And so it's no longer pure survival, but it's sort of the abstract notion that I think drives both scientists today is pure knowledge for its own sake and wanting curiosity. I'm using too many fancy words. Curiosity is what I'm trying to get at. In addition to survival, curiosity at some point. But you can view it as a spin-off of the need for being curious about possible future scenarios that might affect survival. I wonder if cavemen knew that the ice ages were coming and planned migration to go to better climates,
Right.
or just go in all directions, and the ones that went the wrong way got killed off, or whatever. There's some interesting things. So to me, that you can understand the purpose of life in that sense, but the meaning of life is to me is a more remote and less graspable concept that I don't think science really deals with.
Right. No, thank you. That's also a great perception or a point of view about meaning of life. So who knows? There is no evidence. There's no research about why, it is all being created. It just happened and we are part of it and we are able to comprehend it. So we should be thankful about it. Yeah, but this is how we end our podcast. Jeffrey, I had such an amazing time asking you these questions, learning all these things from you. Do you have any parting thoughts with us?
Oh, well, just your last point and the way you expressed it, I totally agree with.
Sure.
If you try to think about, this sort of glib answer about the total energy of the universe being zero is just that. It's a glib answer. But what went on before? I think I can rule out certain things that a gray-bearded man sitting in a throne waved a magic wand and the universe was created. I don't think that happened, but I do think that it's an unanswerable question in a fairly fundamental way, given what we know now, and maybe, but whether it's it's still something that you have to think about, and maybe some of the drive to find new ways of learning about the universe that characterizes modern astronomy. Maybe part of that drive is to be able to understand things that we currently don't have any way of getting any information about them. So you can easily say, well, I don't need to bother to study the question because I'll never get an answer to it, but maybe we can find answers sometime in the future. So anyway, just thank you for your questions and your podcast. It's very interesting. I enjoyed it a lot.
Right. Thank you so much, Jeffrey. Thank you for coming. And if your schedule permits, we can, again have such a talk so that, our listeners can then get enlightened with your views about space and technology and several other things. So thank you, Jeffrey. Have a great day.
You too. Thank you.
Thanks. Thank you for listening to this podcast. Please support this podcast by liking, commenting, sharing it with your friends, and also subscribing to this channel. Thank you, and we'll see you next time.